am Vvsma from Gopanahalli, Vision Village Schoolmaster Academy. Classes for competitive examination students who are interested to face the examination of IAS and KS and other competitive examinations for the subject science and technology. I am Vvsma welcoming you to Vvsma Academy. Spectroscopy. ದೃಷ್ಟಿಗ್ರಾಮ ಶಿಕ್ಷಕ ಶೈಕ್ಷಣಿಕ ಶಾಲೆ, ಕಲೆ ಮತ್ತು ವಿಜ್ಞಾನ ಶಾಲೆ ಸ್ಪೆಕ್ಟ್ರೋಸ್ಕೋಪಿಯ ಬಗ್ಗೆ ಒಂದು ಇಣುಕು ನೋಟ, ಒಂದು ಪಕ್ಷಿ ನೋಟ, ದೃಗ್ವಿಜ್ಞಾನ. ಬನ್ನಿ. ಫ್ರಾನ್ಹಾಫರ್ ಲೈನ್ಸ್ discovered by a German physicist and optical lens manufacturer by name Fraunhofer. He made optical glass, an achromatic telescope, and objective lenses. He also invented the spectroscope and developed a diffraction grating. In 1814, he discovered and studied the dark absorption lines in the spectrum of the sun, now known as Fraunhofer lines. This is telescope. This telescope is purely based on spectroscopy. It is used to measure the distance between the heavenly bodies in the space and to the earth. The Fraunhofer lines are a set of spectral absorption lines seen in the optical spectrum of the sun. Distinct, clear lines, dark lines, A, B, C, D, E, F, G, H, K. The lines ionized calcium with wavelength 3933, CH band 4300 angstrom units, neutral ions, neutral magnesium, neutral sodium, terrestrial oxygen, etc. These are all the dark bands found in the Fraunhofer lines. Fraunhofer lines are fascinating features observed in the solar spectrum. Let's delve into the intriguing story. What are Fraunhofer lines? Fraunhofer lines are a set of spectral absorption lines seen in the optical spectrum of the sun. These lines appear as dark bands at specific wavelengths. They are formed when atoms in the solar atmosphere absorb light emitted by the solar photosphere. These lines are named after the German physicist Joseph von Fraunhofer, who first discovered and observed them in 1814. The solar spectrum, sunlight from the sun as seen on Earth. In 1802, English chemist William Hyde Wollaston noticed dark features in the solar spectrum. Joseph von Fraunhofer independently rediscovered these lines and meticulously studied and measured their wavelengths. He mapped over 570 lines, designating the most prominent ones with letters from A, B, C, D up to K, and weaker lines with other letters. If you observe sunlight transmitted from the photosphere, atomic elements in the transmission path, an electron-dense layer, the visible reaction zone named the photosphere, the solar interior, a dense plasmasphere, the solar chromosphere of the dense magnetic action, the solar plasma corona. These lines result from selective absorption of light by chemical elements in the solar atmosphere. When light passes from source, sun, to the detector, certain valence are absorbed, creating these dark features. The gas in the sun's atmosphere and outer photosphere contributes to the formation of Fraunhofer lines. Friends, prominent Fraunhofer lines are seen to be major Fraunhofer lines, prominent, and their associated elements: sodium D1, sodium D2, another sodium absorption line 588.995 nanometer, H-alpha hydrogen absorption line at 656.281 nanometer, G absorption line associated with the calcium. Next, sodium absorption in star spectrum is enhanced by sodium in planet's atmosphere. Well, friends, significant Fraunhofer lines provide crucial information about the composition of the sun's atmosphere. They also serve as a bridge between the astronomy and chemistry. It is the link, golden link, that is a bridge between the astronomy and the chemistry as they reveal the presence of specific elements. These spectral fingerprints continue to captivate scientists and stargazers alike, unrevealing the secrets of our celestial neighbor. What electromagnetic radiation warms the atmosphere? Why is the wavelength of the infrared radiation emitted by the Earth absorbed by the atmosphere to cause the greenhouse effect? But infrared radiation from the sun is not absorbed by the atmosphere if it emits infrared at all known wavelengths. So, electromagnetic spectrum consists of gamma rays, X-rays, ultraviolet radiations, infrared radiations, microwaves, and radio waves. Fraunhofer lines are highly fascinating phases as we discussed in the solar spectrum. Let us delve into the intriguing story he explained earlier. These are the single slit diffraction, Fraunhofer diffraction. Fraunhofer diffraction explains the wavelength absorption lines, hydrogen, sodium, and calcium. Thank you, friends, for listening about the Fraunhofer lines in the spectroscopy, an extraordinary, sophisticated studies of the solar spectrum. Thank you.